Hi, Brandon Clayton here, the Algebra Guy. Today, as you see on your screen, the lesson is solving quadratic equations, but this time using the quadratic formula. It's an interesting formula that was concluded or deduced from the standard form of an equation, but we're just going to use it today. The skill that we're covering is still 8A. Solving quadratic equations, having real solutions, but this time we're applying the quadratic formula to it. So let's get to it. So what is the quadratic formula? So right here you see the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now I could have gave you an intro into how that equation came about, but I don't think you'd be interested in that. We're just probably interested in solving it. But to give you a light overview, they took the standard form of, let's be x plus c equals 0. They took the standard form and basically they solved for x. So when they subtracted c, got the factored out of x divided by a and b, they did all this stuff right here and they got this beautiful equation you see here. So that's how they got it. But again, most people aren't interested in that, but we are interested in how do we apply the quadratic formula to actually get our solutions. Up to this point, we've talked about using the square root method or factoring. Now we're going to talk about square root quadratic formulas. We're also going to talk about how to use a calculator in another lesson, so stay tuned for that. So let's get to it. As you notice, we have in our, let me write this again, bx plus c equals 0, the standard form of a quadratic equation. That's a 0. Notice that we have an a, b, and a c. So that's what these letters are referring to when you see them in the quadratic equation. So all we're going to do is identify those letters and plug them in. I want to work about 4 or 5 problem examples with you of different types so you can know how to handle it no matter how you receive it. So first we're going to start each time by identifying our a, b, and c. So I always like to start this way. And our a here is going to be a 2. As you can see, it's in front of the x squared. Our b is a 9, and our c is not a 5, but a negative 5. Now all we do is plug that into this piece here, and we just solve it. So let's do that. We got negative b, so that's going to be negative 9, plus or minus the square root of b squared. B squared is 9 squared. I'm going to go ahead and write 81 if that's okay with you. Actually, I'll write 9 squared. Just to make sure I show every step. 4ac all divided by, all of this divided by 2 times a. 2 times 2 in our case. So how do we simplify that even further? We like to start with the radical. One of the reasons we like to start with a radical because it's the most difficult looking thing. But that's just the ideal place to start, even using PEMDAS. But another reason is because if you get a negative value under that radical, you might as well stop, because if you remember, we can have a square root of a negative value. So we'll stop there. So this is the first thing we want to do. So let's start by simplifying that piece there. 0 given negative 9 plus or minus the square root of 81. This is, let's say negative 4 times negative 5 is a positive 20. Positive 20 times 2 is 40, so we end up with a positive 40 because this negative times this negative gives us a positive, and all divided by 4. So we break that down even further. Plus or minus the square root. 81 plus 40 is 121. I should have just did this radical by itself so I don't have to write out everything. So now I know that negative 9 plus or minus 11, because 11 times 11 is 121, all divided by 4. So now I got 2 problems, and I want to separate those 2 problems. So I got negative 9 plus 11 divided by 4, and I have negative 9 minus 11 divided by 4. So we want to get both of those solutions. So negative 9 plus 11 is a 2. 2 over 4 is, it equals 2 over 4, which is going to give us 1/2. So that's one of my solutions that I can find using the quadratic formula. The other is negative 20 over 4, which is going to give me a negative 5. So these are the 2 solutions that we can conclude by using the quadratic formula. All right, so let's try this one. Same thing, I'm gonna start out, and I like to give a lot of problems because the practice is so necessary. You'll run across different types of problems and you'll think, I haven't worked one like that before, but once we go through it, it's pretty easy to see the patterns. So let's set this up. I got my A, B, and C identified. Now I'm going to set negative B. Now watch this. So this is one of the situations that students mess up on, is it says negative B, but we already have a -5, so we'll just say, oh, -5, but that's not the case. This is -5, because that negative is already there, and this is our B. So of course that changes it to a +5. So we're just going to write 5 here, plus or minus the square root of B squared. So -5 squared is 25 minus 4AC, -3, all divided by 2A, which is 2 times 4. And let's just do the radical this time. So I'm just going to start with under the radical, and I see we got -4, -3 is a +12. 12 times 4 is 48. 25 plus 48. What's 25 plus 48? 8. That's 13. Is that can't be right. 8, 19, 11, 13, 4, 6. I guess so. So 73. So this makes it a lot easier now instead of me constantly rewriting this. So this is square root of 73, all divided by 8. So I'm going to go ahead and break this into 2 problems. And one is going to be 5 plus the square root of 73. 73. Let's rewrite that. Square root of 73 over 8. And 5 minus square root of 73. Why do I keep writing 3? 73 all over 8. So you could honestly, this is justification for the answer. There's nothing else you can do with it, but here's the other 2 ways that you're going to see it as well. So there's nothing I can do with that 73, so I'm just going to have to leave it that way, and that's the right answer. Now you might see it separated, right? 5 over 8 plus square root of 73 over 8. So that's another way, but it's usually written all together just like this. All right, so again, what about this problem? So that last one was interesting because it didn't come out to a nice number or even a fraction. It was a radical, and sometimes that would happen. So let's look at this problem. A equals 2, B equals 10, and C equals 11. Now I would encourage you to pause it here, see if you can work this yourself before I do so. Now, I know what you're probably thinking. You may not want to use this way, and I don't blame you. Factoring may be easier, definitely a calculator method, but some of the answer choices are in quadratic form, have a quadratic form look to them, and I'll show you that at the end of this lesson. So you want to be at least familiar with it when you get to it. So let's do this one, -10 plus or minus the square root of B squared, which is 100, minus 4 times 2 times 11, all divided by 2 times A, which is 4. So I went ahead and multiplied these and squared that, if you don't mind, just to save us an extra step. 100 minus what? What is this? 4 times 2 is 8. 8 times 11 is 88. 100 minus 88 is going to be 12. So we already know underneath that radical it looks like it's 12. Let's do that again. So 11 times 4 is 44. 44 times 2 is 88. 100 minus 88 is 12. So I'm going to say this is -10 plus or minus the square root of 12, all divided by 4. Now again, this is a good enough answer for some answer choices, and I will leave it that way. However, we talked about how we can simplify this radical of 12, so let's go ahead and do that. So I know there's a perfect square in there of 4, so we're going to do the square root of 4 is 2, and that gives us 3. So you could rewrite this piece as 2 square root of 3, and you can also simplify 10 over 4. So it just depends on, at this point, it depends on the answer choices you're given. This may be enough, or you can see it like this, 2 square root of 3 over 4. Or you can see 10 over 4 simplified. So you can see or let me rewrite it all the way out. Negative 10 plus 2 square root of 3. So this is going to be over 4, and this is going to be over 4. And you have negative 10 minus 2 square root of 3. And this is over 4, and this is over 4. So you can see how these can simplify, because 10 over 4 was simplified to negative 5 over 2. And this 2 and 4 was simplified to square root of 3 over 2. Now notice I didn't write a 1 there, but you should be thinking this is 1/2. But we don't usually write a 1 there when representing a number in front of the radical. Just like we do with the variable x, we just leave it x. So we're gonna, this is another way you might see it, and simplifying this again, and minus square root of 3 over 2. So just be familiar with the various ways you can see it. I've seen it a few different ways, but know that these are the answers that they're looking for. I think I missed one. All right, so we can take the square root of a negative number. So I mentioned that before, and that's why we want to start with that radical. This one will work out to a negative, and I want you to see what that's going to look like. So if I had b squared, this is 4 plus or minus the square root of b. I said b squared. It's not b squared. It's negative b. Negative b, so it's negative 2. And then b squared, 4 minus 4 times ac, which is 9, all divided by 2a. So let's do the inside first. We get 4 minus, what is this? 9 times 4 is 36. 36 times 3 is 108. 4 minus 108 is going to equal, negative 104. So the fact that this answer under here is negative, you can stop there because it's not going to be a solution. You can't have two numbers multiply to get a negative, so there's nothing else you can do. So that makes that problem pretty simple. So just be aware that those problems are out there. What do you do if you have fractions? Ooh, who wants to put an a, b, and c as a fraction and square all that? Right, so who wants to square this and do a negative? And who wants to do that? Well, the good news is you don't have to. In standard form, we want to have, when you have your ax squared plus bx plus c equals 0, you want to have all these numbers be whole numbers. So in order to have that, make that happen, we're going to multiply both sides of this equation by the least common multiple of your denominators, 2 and 3. So the least common multiple that they have in common is 6. So if I multiply by 6 on each side, then it'll help me change these fractions into whole numbers. So 6 times 1/2 is the same thing as 6 divided by 2. So that's 3u squared. 6 times 2/3 is the same thing as 6 divided by 3, which is 2, times 2, which is 4u. And 6 divided by 3 is 2. So this is a little bit easier, and I'm going to put it in standard form so I can identify my a, b, and c by subtracting 2 on both sides. Now I know my a is 3, my b is 4, and my c is negative 2. I can proceed with my quadratic formula. Negative 4 plus or minus the square root of b squared, which is b squared minus 4 times a times c, negative 2, all divided by 2 times a, which is 6. I'm just going to say that's 6. So I'm going to do my radical under here first. So that's going to be 16 minus, let's kind of look at this, 4 times 3. Let's do the negatives. Negative 4, negative 2 is positive 8. 8 times 3 is 24. So we got 16 plus 24 because this negative sign changes because of those two negatives multiplying together makes it a plus. So we got 16 plus 24. What is 16 plus 24 going to give us? It looks like it's going to give us a 40, right? Because this one's going to carry. So we end up with negative 4 plus or minus the square root of 40, all divided by 6. And again, this is a beautiful answer, just like that. However, we can simplify the 4 and 6, and we can take out some perfect squares from this square root of 40. And I'm going to go ahead and show you that. I'm going to leave it in this form because I think this is more ideal. And I'm just going to take out the perfect squares here, plus or minus the square root. So let's say square root of 40 breaks down into, what's the biggest? 4 maybe, square root of 4. It's probably a big one. 4, 16, no, probably it. So 4 and 10, so the square root of 4 is 2, and we got 2 square root of 10. So this is going to be, erase this, 2 square root of 10, all divided by 6. Now, when I have it this way, and I'm glad I did this actually, because this is pretty popular. When I see this, I see 4 over 6 and 2 over 6, and they're definitely going to want to simplify that oftentimes. So simplifying that will look like this. What's 4 over 6 simplified? That'd be negative 2 and plus or minus, and 2 over 6 is just going to be 1, because 2 over 6 is going to go to 1/3. So this is going to be 2 over 3. These are both going to go to, let me make sure, 4 over 6 and 2 over 6. So divide this by 2, that goes to 2, divide that by 2, goes to 3, and yeah. So you're going to have a 3 on the bottom for each one. So this will be more common right here. Since they both have the same denominator, you might see this answer. So I don't want you to get confused if you see something different from what you have. You may get this and think, I don't see my answer. But all they did was simplify their fractions when you separate it, because this is a fraction here and there's a fraction here with this 1, or better yet, there's a fraction here, 2 and 6, and negative 4 and 6. So keep that in mind. All right, star problem. What does it look like on the star? How can I be ready for that? So what are the solutions to the equation x squared minus 4x equals negative 1? So look at the answer choices. So we talked about this would happen. They would give you answer choices like this, and believe it or not, this is a this was a highly missed question, probably because of this format that looks so weird. And oftentimes in class, we as teachers don't spend as much time on this because it doesn't show up often. But man, when it did, the students really were hurting. So I want you to get an absolutely 110 on this test. So we're going to make sure we're thorough. All right, so identify my A, B, and C. A, B, and C. Now I want to encourage you at this point, please work the problem before I do and see which answer you come up with. Will you be in the top echelon who get this right? So I will work this and see if you can come up with the right answer first. All right, my A is 1, my B is negative 4, and my C is 1. Now I bet you can, because a lot of them did not understand about the quadratic formula and what this looks like, but you are different. You definitely know how to set this up. So negative b, that's going to change the sign to just 4. That's 4 plus or minus the square root of b squared. Well, that's going to be 16 minus 4 times my a, which is 1, times my c, which is 1. Oh, that's easy, right? So all divided by 2a. 2 times a is just 2. You know what? I just realized I don't have the formula up here. Sorry about that. From doing this a long time, you just end up remembering it. So b squared minus 4ac. And the formula is made available to you during the test, so you don't have to worry about that. If I remember correctly, I just want to say that unless they change it. All right, so let's simplify this and see which one is the right answer. 16 minus 4 is 12, so this would be 4 plus or minus the square root of 12 all over 2. All right, so look at this situation. Before I've simplified this radical or simplified these fractions, if I look over here at my answer choices, you'll actually find, I believe, let's see if we can find it. Yep, we have a positive 4, and there it is. So what were they banking on with this 20? They were thinking that some students are going to mess up on this negative. And let me make sure I didn't, first of all. So 4, 16, we got A times C. Yeah, so we're good. 16 minus 4. So they were banking on students messing up on adding or subtracting what's under the radical. So we got the right answer. And that's how you would do it. That's how it looks on the star. All right, so did we complete what we sought after to do? Yeah, we solved quadratic equations having real solutions by using the quadratic formula. Great job. My name is Brandon Clayton, and I will see you next lesson.